Hello, my students and listeners at home. Welcome to online teaching from St. Charles College, Onitsha, from Department of Mathematics. My topic is Probability 2 by Anyabolu. Then here is my specific objective. At the end of this, students should be able to 1. Define mutually exclusive and independent events. 2. Solve problems on mutually exclusive events and independent events. Last time we talked about single events. In this probability 2, we talk about combination of events. 2 or more events which are subset of a sample space can be combined using set notations, union and intersection. For instance, if E sub 1 subset of sample space and E sub 2 subset of sample space, then E sub 1 union E sub 2 is the event of either E sub 1 or E sub 2 or the both occur. B, E sub 1 intersection E sub 2 is the event that E sub 1 and E sub 2 occur. Then mutually exclusive events. 2 events A and B are mutually exclusive events if the occurrence of one implies non-occurrence of the other. That is, they cannot happen at the same time. In this case, simultaneous occurrence is impossible. Therefore, probability of A and B is 0. That is, probability of A intersection B is 0. The probability that A or B will occur is the sum of their probabilities. This leads us to addition law on probability. Addition law on probability, where we have either stroke or. Addition law states that the probability of getting either A or B or C or ... is equal to the probability of A plus probability of B plus probability of C plus ... provided that they are mutually exclusive events. In the set, we have something like this. N in bracket A or B equals P or N of A plus N of B minus N of their intersection. And the same thing applies to the probability of A or B equals probability of A plus probability of B minus probability of their intersection. If they are mutually exclusive events, P of A or B is equal to P of A plus P of B. Since in mutually exclusive events, A in P intersection A is equal to 0. We said that the events are disjoint. Examples. Find the probability that a letter chosen at random from the alphabet is either a vowel or one of the letters S, Y, Z. Solution. The sample space equals A, B, C, ... to Z. The number of elements in the sample space equals 26. Let B be set of vowels equals A, E, I, O, U. Number of elements in V equals 5. D equals the set of S, Y, Z. Number in D equals 3. Probability of getting vowel or X, Y, Z, which is D, equals probability of V plus probability of D. Probability of V is 5 over 26 plus probability of D, which is 3 over 26, that is 8 over 26. Then you simplify it to 4 over 13. Example 2. A number is chosen at random from the set of even numbers from 2 to 20 inclusive. That is the set x equals 2, 4, 6, dot dot to 20. Find the probability that it is either a factor of 18 or multiple of 5. Solution. Sample space x equals 2, 4, 6, 8, 10, 12, 14, 16, 18, and 20. Then f equals factor of 18. The factors of 18 from the sample space are 2, 6, 18. The number of elements in the sample space is 10. And the number in f equals 3. Then for multiples of 5, m's of 5 equals 10, 20, the number of elements in m equals 2. It follows that m and f are mutually exclusive. That is, they have nothing in common. Therefore, P of f or m equals P of f plus P of m. P of f is 3 over 10 plus P of m 2 over 10 equals 5 over 10. You simplify to 1 over 2. Note before. Use addition law to solve problems that contain the word either, stroke, or. Then the case where they are not purely mutually exclusive. Example 3. A number is chosen at random from 20 to 30 inclusive. Find the probability of getting a prime, B a multiple of 3, C even numbers, D either a multiple of a prime number or multiple of 3, E either a multiple of 3 or an even number. Solutions. The sample space equals set of 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30. A question. Prime numbers are equal to 23 and 29 from the sample space. Then probability of getting prime is 2 over 11. B, multiples of 3 equals 21, 24, 27, and 30. Then probability of multiple of 3 equals 4 over 11. D, even numbers are 20, 22, 24, 26, 28, 30. Probability of getting even number, that is a number, that is 6 over 11. E, probability of either prime or multiple of 3. That is probability of prime plus probability of multiple of 3. So the probability of prime is 2 over 11. Probability of multiple of 3 is 4 over 11 equals 6 over 11. Since they are mutually exclusive, the number F, probability of multiples of 3 or even numbers, that is equal to probability of multiple of 3 plus probability of even numbers minus probability of their intersection. Therefore, probability of multiple of 3 is 4 over 11. Probability of even numbers 6 over 11 minus probability of multiple of 3 intersection even number, which is 2 over 11. That is equal to 4 plus 6 minus 2 over 11 equals 8 over 11. Independent events. Two events A and B are independent events if the occurrence of A does not affect the occurrence of B. That is, simultaneous occurrence is possible. Then the probability of A intersection B is equal to probability of A times probability of B. This leads us to multiplication or product law on probability. Product law on probability where we have the words and stroke both. Product law states that probability of getting A and B and C is equal to probability of A times probability of B times probability of C. Example, a die is thrown and a coin is tossed. What is the probability of getting both a 6 and a tail? Solution. The table below contains all the possible outcomes. The first row is the die, numbers on the die. First column is head and tail for the coin. So when you toss two of them will happen at the same time. They can have head 1, head 2, head 3, head 4, head 5, head 6, tail 1, tail 2, tail 3, tail 4, tail 5, tail 6. The probability of getting both a 6 and a tail. In the sample space, we have a total 9 of x is equal to 12. The probability of getting both a 6 and a tail is only one place that have both a 6 and a tail. That is equal to 1 over 12. Or you can use probability of getting a 6 is 1 over 6 times probability of getting a tail, which is 1 over 2. So 1 over 6 times 1 over 2 is equal to 1 over 12. Example 2. If two coins are tossed, find the probability of getting 2 heads. B, a head and a tail. C, at least 1 head. Solution. The sample space is shown below. You have coin 1, you have coin 2. They're tossing the two at the same time. They happen at the same time. The sample space, you have head, 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 tail, tail, head, tail, tail. A solution, probability of getting 2 heads. Only one place that you have 2 heads. So that will give us 1 over 4. Probability of getting a head and a tail. We have head and a tail into 2 places. So we have 2 over 4. They simplify it to be 1 over 2. Probability of getting at least 1 head. You see that in the sample space we have, where we have at least 1 head, where I have head, tail, tail, head, more head is head, head. So in that case, we have 3 of them. So the probability is now 3 over 4. Example 3. 2 dice are thrown at the same time. Find the probability of getting A, the same number. B, the different numbers. 2 5s. Next, at least 1 5. Next, a total score divisible by 5. Next, a total score greater than 10. And next, a total score of 3 or 8. Solution. The table below shows the sample space. The first row, we have first die. Second row, we have first column, we have second die. Then when you toss that, you see the sample space can have 1 1 1, 1 2, 1 3, 1 4, 1 5, 1 6, 2 1, 2 2, 2 3, 2 4, 2 5, 2 6, 3 1, 3 2, 3 3, 3 4, 3 5, 3 6, 4 1, 4 2, 4 3, 4 4, 4 5, 4 6, 5 1, 5 2, 5 3, 5 4, 5 5, 5 6, 6 1, 6 2, 6 3, 6 4, 6 5, and 6 6. The total number in the sample space is 36. The probability of getting the same number on the dice. That's where you have 1 1, 2 2, 3 3, 4 4, 5 5, and 6 6. So showing the same thing. How many places? We have the number of required outcomes there is what? 6 into 6 places over the total number in the sample space, which is for 36. Then you simplify it to 1/6. View question getting 2 5s. How many places do you have 2 5s? Only one place where I have 5 5. The number of required outcomes there is 1. Total number of possible is 36. So the answer is 1/36. Then D, at least 1 5. Under the sample space, where I have at least 1 5 is where I have 5 1, 5 2, 5 4, 5 5, 5 6, 6 5, 4 5, 3 5, 3 2, 1 5. Total of 11. So the probability is 11/36. Then E, probability of getting a total number divisible by 5. Numbers divisible by 5 are 5, 10, 15. So where we have a total number divisible by 5 under the sample space is where we have 1 4, 2 3, 3 2, 4 1, 6 4, 5 5, and 4 6. Number of required outcome is what? 7. Over the total number of possible outcomes, which is 36. So the probability is there is 7/36. And F, probability of getting a total number greater than 10. That's why we have a total of 10 and 11 and 12. So total number greater than 10 is now where I have 5 6, 6 5, and 6 6. The number of required outcomes, 3, there are 3. And total number of possible outcomes is 36. Then you simplify to 1/12. Then the next one, probability of getting a total score of 3 or 8. That is the places where you add, give you a total of 3 and or total score of 8. So we have the required there. So why we have 2 1, 1 2, 6 2, 5 3, 4 4, 3 5, 2 6. The number of required outcomes there is 7. Total number of possible outcomes, that is 36. So the probability is 7/36. Number, for example, a number is selected at random from each of the sets 2, 3, 4, and 1, 3, 5. Find the probability that the sum of the two numbers is greater than 3 but less than 7. They have the first row as 2, 3, 4. First column 1, 3, 5. Then you sum 1 plus 2 is 3, 1 plus 3 is 4, 1 plus 4 is 5. 3 plus 2, 5, 3 plus 3, 6, 3 plus 4, 7. 5 plus 2, 7, 5 plus 3, 8, 5 plus 4 is 9. Then you see the places where we circle. That is where we have required outcomes. The total score greater than 3 but less than 7. Then the total number in the sample space equals 9. Probability of getting total score greater than 3 but less than 7. The number of required outcomes there is 4. Over the total number of possible outcomes, which is 9. So the probability is 4/9. Answer all the questions under the evaluation and submit it into my WhatsApp. My WhatsApp number is 08065130202. Thank you.